Thank you, everybody. Thanks for joining. I'm glad people stuck around for the Friday. You know, I've taken a lot of takeaways from this, right? I learned a lot of new insights. I've gained a new belt size. I have appreciation for how much sour cream a person can consume.
I like food. I don't know, I can't help it. It's been pretty good food, too.
Yeah. So just kind of an overview of us. I'm a manager of CRE, and this is my boss. I'm kind of the problem solver. So my claim to fame in our team is that I use Vim. My hands hurt. I used Vim. No more carpal tunnel. It's perfect. And then there's Troy Koss.
Yeah, I tend
the
to be a
source of all my problems is my manager.
Yeah. I tend to be a problem creator, right? Had a simple service, said Kubernetes, right? And I think everyone's probably made that mistake by now. And if
Don't we have something right now going on?
There might be, but we're not going to talk about it.
Okay.
And yeah, if you do run into a simple service on Kubernetes, get rid of it. Cautionary tale there. So we'll first start with talking about what is SRE. We've heard a lot of it this whole event. We've heard different flavors. There's platform engineering, there's DevOps, there's whatnot. And what we've kind of done internally is anchored on some set of just core practice areas that, as an SRE, right, what do you do? What's your identity? What are the things you work on, right? It's not that stuff up there, right? We don't work on elephant-sized feces. Like, it's not just the low-hanging fruit. Your job is not to just work on toil, right? It's to help get rid of it. And there's a whole bunch of different things. It's the risk management side, it's the release engineering, it's the resiliency you need for your architecture. And what we're going to talk about today, more specifically, is the reliability measurement, right? How do we measure reliability? What does reliability mean? We can talk about that too, but ultimately, for your customer, what does that reliability measure? And in doing so, in our journey, it's been a lot about, okay, SLOs, they're great, they're fantastic, right? And I fell into the circular sales strategy trap, right? Which is, SLOs are great because, right? And you start using them, you put them out there and you're like, this is awesome, but like, what about all the pieces that make them effective? And ultimately, this is a loop that's dangerous. You can fall into this and it'll help you fail and real fast. And at the end result is that you're ultimately not successful in adopting. So our story today will talk a little bit about our journey, what we went through, how to avoid this, and kind of develop a actual strategy around adopting something new into your organization, right? And it starts with studying the industry. What are people doing? Why was that a talk topic? Why did you learn about that or read that? How do you experiment, right? And then ultimately fail a bunch of times, right? I think all of us are probably rooted in the fact that as SREs, you're going to fail. Things are going to fail. Things will break, right? And how do we experiment with that and fix those problems and iterate on that and loop on that? And then lastly, in this domain specifically, what are the signals that these metrics are going to give us? What do we get from an error budget? How do we act on it? What are the things that are important to us? And lastly, besides the fanfare and excitement and actioning on these things, how do you scale it? And that's been our big dilemma at a large company with thousands of applications. So.
That seems hard. How would I take over that? You must be a problem creator.
Yeah, that's up to Mike.
So let's start looking at what does industry say. So when Troy threw this at me, I was like, okay, let's Google SLOs. Well, what comes up? Nice little chart. All right. How many of you guys are familiar with a similar chart like this? Right. Yeah. So. And that was kind of my impression, about 32 minutes of y'all. It doesn't really make sense to me. And so I want to do a little reenactment of when I saw this and what my thoughts were. So let's find me in my natural state. Confused, that's pretty much me most times. So I'm actually-
He's not wrong. He's not wrong.
I'm actually a recovering architect. And so what's in my head is pictures. Right? Look, I've even got 2 cylinders for the database. It's perfectly replicated. That's easy, right? I don't know what y'all's problems are. So, there's always something broken, usually not the whole thing. So, I got my traffic in here, and it took me a couple hours, but I counted, and I said, hey, there's 3 broken transactions. That gives me 9 out of 12 requests are working.
Yeah, and then he just complained, right? And it was like, this isn't going to work. We don't need this, right? But I kept on saying, do it, as any management would do, right? Keep doing it, work, or be afraid.
I think there were some references to the military style of beatings will continue until you solve it.
Yeah.
So, but turns out he was right, as much as I hate to admit it. There's more to it, right? If we look at any continual Google fooing, you'll find that you start with an SLI, good events over valid events times 1,000, or 100, which matches kind of my expectation. Then you set a target to it or an objective, 0 to 100. And then that gives you an SLA. Is that what those are? No, those are for lawyers. That's just whatever the lawyer thinks up. Doesn't have any relation to it, other than it's got an A and an L. So what it really gives you is an error budget, right? And then we get back to our chart. Wait, I'm not good at math, so I actually had to Google and get help from Duke University. And answers where you have one unit on the left side of the equal sign and another unit on the right side are just plain crazy. But you know what? I do know one math property, the transitive property. So if you look at that, you get SREs are really just a combination of SLOs and error budgets, right? And if you go to the next one, it is SLOs and error budgets are crazy, according to Duke University. So transitive is SREs are crazy, right?
It's good to be different.
You know what? I know a crazy SRE. Can you help me with this, Troy?
Yeah, I'm gonna try. I'm gonna do my best, right? So we took the formula and we said, okay, now that we have this formula for SLIs, let's start there at the root of it, and let's align to time. Okay, we're gonna put these indicators across minutes, and just a sample set here, and this is all totally fake data, right? I have to say that because you know why, right? And the good over total, when we look at that over a span of a few minutes, and then we say, well, what's a good minute or a bad minute? We say, oh, a good minute is at 95% of them, right? And then we just magically forget about the other 5% because, you know, that's okay. And then lastly, we say, you know, there's probably other strategies, but this is already just off the rails and we're not sure how this makes sense. And there's a lot of good material out there. Alex, who's here, right, they have a book on SLOs. We shout out to Sam from our team who leads a book club on the topic. We did a lot of those sessions to like learn and educate across the teams. But there's a lot of different ones, but like this was kind of a first crack at it. You're like just getting the units right. And then we ended up with this SLI, and we're like, I was like, Mike, I quit. This doesn't make any sense. I give up. This doesn't make sense. Like maybe we should throw in the towel. And again, I've created another problem, right? That's my job.
Well, and at that point, maybe we just really suck, right? Maybe the SLO is for a system is 66. But let's experiment and test this out, right? So we're going to be sciencey. Not perfectly science, just sciencey. That's business style, right? So the first thing we did is, what is our question? Well, is error budget actually in events or is it in time, right? For us, right? My assertion of this is, first, it shouldn't have to be perfect to work, right? If it's got to be perfect, it ain't working. And then the next question is, it should correlate to what we currently know about system health. What do we know? We know incidents, we know changes, we know personal impressions. They're always, maybe, sometimes, sort of, kind of. They're indicators, right? They're signals. So let's test this out. First, let's grab some real data. And you'll notice there's no units for, as you mentioned, you know why. But this is traffic with over a 30-day period of a bad event and a baddest event. So we wanted to see what it looked like when there was stuff going on that we could signal off of. So using this data, you'll see on the left side is in blue the good events in terms of non-500s, and in red is the 500s as bad events. And so if we look at this, we said, hey, let's apply that time stuffing, slicing strategy, whatever you want to call it, that my crazy boss came up with, and see if it works. So what does we get? We get what we lovingly call the L graph. It forms a bunch of L's, right? And you see we had our badder incident, and in the dots, you actually see the bad incidents, which we're not going to talk about right now, but we also see the baddest. And what happened is there's no signaling. It ignores everything until we get our baddest, and then just panics. We actually get more information out of changes in incidents than we do out of this SLO. That doesn't seem like that's the right way to do it.
Yeah, and I think when we go back to look at what happened, right, there's two like real big fallacies here. There's like, one is, okay, we've eliminated some of our errors and we're not paying attention to them, so that's not good. And the other is, these aren't the same weight, right? If you think about a mass event that's happening, a lot of traffic on your store, whatever your event may be, a Super Bowl, whatever, like, they're not the same minutes, right? And that's ultimately what we're trying to convey here, is that not all minutes are equal. Like, the 1 minute, 4,400,000.
Isn't that in the title?
That's kind of where the title came from,
okay.
yeah. And then for dramatic flair, ooh.
Ooh. Yeah.
We can do it one more time, right? Ooh.
Yeah.
But yeah, not all minutes are equal, and that's what we really learned, was that formula, that approach, that strategy wasn't working. So again, as all good management does, you tell your people to fix problems.
All right, well, delegating up didn't work, so I guess I gotta fix this. So kept researching, went to the drawing board, went through the book study, right? And we said, well, there's actually more to it, right? So there's formulaic representations of this stuff. So if you look at SLI, we've seen this before, it's good over total. You have the objectives, that's very clear cut, right? Well, the error budget helped, right? Now we have a formula for it. It's 1 minus objective times that's total, straightforward. To give an example, right, you had 100,000 requests, 10 were bad, you get your SLI, and we say an objective of 2 9s and a 5. That gives you 500 allowed errors in that period of time, right? What is your error budget remaining? That's 500 minus 10. And we do this so that we can show a consistent graph of the data as we look forward to it. So I didn't really explain the earlier graph. But what turned out, if we ignore time, essentially, and just graph the traffic and the failures and what mattered to us, we get a new graph. Now, this is what we call the money chart, because this is what has been probably the biggest seller of SLOs that we've seen so far. We look at the same events that we had earlier: changes, incidents, bad events, badder events, and baddest. Now the badder and the baddest correlate. Some of those bad events weren't noticeably not very impactful, right? We have on the left the EBR, the bottom, of course, is time. And this is where we started saying, hey, I see a correlation between what people believe currently and what people need gaps in. We didn't have the intermediate signals. Now we have information. This is an additive that correlates with what's known. This seems like a success. I really think I should, sell this as something I accomplished, right?
No, I will take credit for all of it. But yeah, honestly, it's looking at trends and data. It's looking at patterns. And that's what we were finally able to like provide to teams and understand how your system behaves over time, right? We all often act on a paradigm of, well, we need a paradigm shift rather in like, yeah, it's up and working, or no, it's not, right? To how well is it actually working in between time. And learning and understanding the behavior of the system, not just like being chained to it and like supporting it, right? That's not the goal. The goal is to understand it, improve it, treat it right for our customers. So yes, Mike did solve a problem, and all kidding aside, we're joking with the whole like management thing, but like it's really been a team effort, and it's really like exciting to see this kind of data help teams understand their systems a lot more closer.
And kind of harp on, it's been a team effort. It wasn't just like us team, it's also in the crowd and not here as well.
Yeah, there's a lot of people. There's a lot of people at play here. And then in fact, some of them are here. And then the next challenge was, okay, because I'm good at that, how do we make this software? Like, how do we take software and solve this problem, right? And Kayla, who out there somewhere, decided to start writing some software with the team, and
let's just say it's not quite my, I'm glad it wasn't me.
Yeah. But things fail, right? We talked about that earlier. Things are going to fail. We know things are going to fail. We know we're going to have problems. And this is why we test your code, make sure it's good.
Yeah.
And we look at that same baddest event that we talked about earlier, and our error budget remaining chart was a little off, to say the least. But
we were getting better.
Yeah, improve incrementally. So another problem has been created for Kayla.
So while Kayla's out there solving that problem, I figured, well, what are the actual signals? Let's look in this a little deeper. What can we understand from this? I'm gonna have to see creating problems.
Do something? You're creating a water.
Jeez, you're creating problems. So really, as we looked at this, we saw kind of a lot of great signals, right? things followed what we expected. You had changes, you had incidents that followed it, and then you had a deep dive of your error budget remaining at that point. We call those fast burns, where you just had a dive. We don't have a formal definition of it. That's probably something we should look forward to. Then we also had recoveries. So what's interesting about this graph is each point of it represents 30 days of data, right? So you're actually looking at a 60-day data set. And so what would happen at the points is 30 days, you had incidents and large consumptions of problems rolling off. So you had these spikes in your error budget. And so we call those recoveries. And what was interesting about this particular recovery, there was no associated incident. It was just based on traffic. The other thing is you start to see change-induced slow burns, right? You have a slow burn, which is where it's just trending down over time, and it can even be split by incidents. That's not particularly on this graph, but we do see it on others. And then you see what is the impact of a slow burn in relation to incidents. So we took 2 periods of time. One is the one we've been looking at this entire time, which is that red line. And we introduced another segment of time that had a 3-week window of a slow burn. And it actually consumed more of the error budget, more impact on our customers per our SLI than our baddest incident. No incident recorded next to it, no actual data around it, but what happened is at some point near the bottom, a change went in and quietly fixed it, right? So the slow burned in and they started recovering in the future. And that's actually really powerful, right? And so what we want to do is that the data's great, people are believing it, well now what, right? So we kind of, in review, right, we had our movement, slow burns, fast burns, recoveries. We had the associations. So we've done, in this presentation, changes and incidents primarily. There were other ones that people were asking, bugs, Jira bugs, alerts, like what other business events occurring that might relate to that. Maybe you want to throw Super Bowl weekend on there and see what it was actually doing. And then the next one is how do you action it? What are the 5 W's and how, right? And because the world is not complete without another obscure acronym, we put one together, right? So Troy's boss is actually a legitimate shepherd. She raises sheep.
Part-time.
And so we said, hey, just remember MA, movement, associations, action. So MA.
Yeah, like a sheep, like meh, or something like that.
Yeah, she does it better.
I've been working on that one all week.
That was our real nervous one, was right there. So, but I think at this time, this is where I throw the celebration over to him, who's much better at it than me.
Yeah. I'm good at stealing it, right? But we were excited at this point. We've defined some actions for teams to move, but how do we give it broadly, right? And we start edging our way into the scale concerns and questions that we're trying to solve for. Again, being large enterprise. And how can we bootstrap teams with defaults? Right? With some of the cases that we originally defined and started working with that you've seen, we got close with the teams, we got intimate with the teams. We were able to say, okay, how does your system work? What are your traffic patterns? And trying to derive better SLIs and ultimately SLOs. But we can't do that for everybody. Systems can scale, but people don't. And burnout's real. So how do we avoid that, all right, and bootstrap the teams so they can at least start using this in practice to start learning about their system? How do we get them rolling? And then we ran into the problem, was like, well, where do we start? Like, how do we do this? We look at their SLI, we can look at the percentiles over the historical time periods and try to take some guesses. But we thought that wasn't really a good, accurate way to do it. And some teams, should it be 98.5? There's people that actually think 5 + 9s are real and possible. There's teams that don't know how well they're performing and are performing poorly. How do you start breaching that topic? You can't go to a team and say, oh, actually guys, it's your SLI is at 65, or that's, how do you do that with an empirical way, an objective way of doing it? And again, I've made another problem to solve, and Mike took a crack at that one.
So what's great about math is you can really reverse formulas, right? So we got our crayons out and took the formulas and used a bunch of paper and then had me do it and then Kayla check it, and then the team really caught all our errors. But what we realized was you'd go to these teams and you show them an SLI and you ask them, what's your objective? I don't know. That was pretty much the answer. They just kind of a blank look, right? So we said, you know what? we're going to pull back an old school waterfall activity. We're going to give it a swag, a scientific wild ass guess. So we said, hey, we're going to put your error budget remaining at 50%. Nobody's going to get mad that you're showing them doing something bad. You're not going to be below the line. It's not perfect. They can say whether they want to improve it or decrease it. So we said we're going to do EBR at 50%, and then we get our SLO default. And what's great about SLO defaults? You can override them.
Yeah, defaults are meant to be overridden. Like change me, right? How many times that happened?
Yeah.
But yeah, the people aspect became the problem, and that's where you have to step in, right? Especially if you're out there in your engineering management, like you have to get involved and you have to help connect the dots with the people. Like shout out to the topic that kicked this all off with the end game. I think it was Amy, right? Like this is a socio-technical problem, right? And the socio-park officing time gets forgotten about, but it's about getting people together in the room and talking about these things, right? We do need some policy, and policy is kind of a cringy word, but it is what it is, right? In that someone needs to know what to do when and how, and we need to document this process. We need to have the accountability to say, like, this is something that I'm going to care about. I care about my customer, right? Not just incidents, or not just the other 8,000 fire drills that every one of you are dealing with every day. That this is the problem. When you look at your air budget and it's falling off of a cliff, we need to come up with a better name than that. But how do you go to your management and say, like, hey, this is happening, we need to fix this? And they're like, well, there's no incident, right? But how do we do that? And then reinforcement. There's a constant churn of people in and out of our environments, and we need to set that down so people that come in and out of the team can actually leverage and understand how the air budgets that are in place are being used for the customers on the products they support. And then lastly, like you said about the defaults, we're just helping teams get started. And that is not our end game. Our end game is to have them evolve them and learn more about their system and change them, right? Your indicators are going to change over time. Your system's going to change. Your architecture is going to change. And in order to do this and make this effective and make reliability part of your features, not like an afterthought, not just like the SRE team's problem, but like everybody's problem, and do that, you needed leadership. You needed dev. You needed SREs, you needed product, you need the people that are working with it and sharing the stories and how the system's supposed to work and behave, right? And bringing all of that together. Right? And then once you start doing that, we can start talking about scale. We can talk about that final pillar, and we could say, okay, we've got the right people in the room, we're talking about the right things, we're just discovering the right indicators, and now we need a process to repeatedly do this. Super easy, it's only 4 steps. We tried to put it into 3, but the 4th one's important. But start simple. It's not perfect. Look, I know some of you out there that are like into this are probably saying, "Ooh, 500s aren't it? There's a whole bunch of stuff." Well, that's probably true, right? But you need a starting point. Some teams don't understand what their system looks like and runs like and operates. Start simple. Start small. Availability, latency. Get your basic ones out there. Get the teams understanding their system and behavior. Understand as you evolve and work with the teams how the system operates, the different layers of it. You're going to have the APIs, the services. You're going to have clients. You're going to have all these different like places to instrument. Some are more ideal than others, and you learn that, you change that, you evolve it. Adding in edge cases, right? There's things you don't know about the system. You'll discover them over time. And then lastly, the most important one is mapping to the customer's experience. It's thinking about our systems from the customer's perspective into it, not our systems and then how are our customers doing, right? And there is a difference there. Steve actually taught me that a long time ago, who's also here on the team. The loop, right? We have this recursive path and pattern that we're following, and it's been really helpful, right? Define the scope, understand the system, understand the applications that are there, instrument them. You need the metrics to do this, not unsurprisingly.
Yeah, and that's when I like to harp on, because you really can't improve what you can't see. So like trying to set an SLI on something you haven't instrumented is really hard.
Yeah, yeah, it's impossible. Assess the baseline. Once you have that there, you can say, okay, where are we at? Where do we need to move? Where does the objective need to be? If you want to evolve and go from 99 to 99.9 and additional and so on and so forth, is there going to be an investment made to help us do that and help us get there? Because it costs something. Understanding the customer's goal is something that takes a long time, but you eventually do solve it. And lastly, that policy and putting that in place with everybody. It's not just a thing for the engineers, just for the SREs. It's for everybody to follow. And then you just do that over and over again. And you keep helping teams and facilitate. We're fortunate enough that we sit in a part of the enterprise where we can go into the different lines of business and help the teams. And if you don't have something similar to that, like, you can still be that evangelist to help this with whatever team you see that might need it.
Yeah, so with that, that's kind of where we are with our process, right? And really, if there's SLOs are kind of a tangential topic to this, really, even though they're the title. But really what we want to focus on is this process of you learned a new thing, you tested it, you studied it, you validated it, you correlated it to something people know and believe already. Most people aren't going to believe your passion topic because it's your passion topic, right? We had to correlate to something they believe, move on. And as you go up the steps of this ladder, everything gets progressively harder, right? You have that loop of validating thing. We showed you 2 examples of the many we did, right? And some of these steps have sub-strategies. So Troy was just showing you our current strategy for handling scaling, right? And that's really an area where this is all kind of coming together. It's built on the bottom layers.
Yeah, it's the process, right? It's not about the specific SLOs like you mentioned. If you take anything off the shelf, you've heard a lot of different hot topics, trendy topics. You're out there talking to the vendors. You're like, woo, AI. I think someone said talk about AI ops and how funny that was. But you have all these concepts, and if you go to try to introduce them and try to bring them in and not understand like what they're going to do, like that's where the failure comes in. You bring it in, you've introduced more noise into your system, and noise brings complexity, and complexity is an anti-pattern to reliability, right? And that's not what we're here to do. So we want to get rid of that and make reliability a main focus.
And that's kind of like an extension of the old cliche of I had a tool, I replaced it with a new tool, and I use it like it's the old one, right? So really, what is it supposed to accomplish? What's its new feature? How are you proving that it's a value? And then scale it with there. So now that we've given you kind of our strategy, we wanted to share some formulas and things that we thought were very useful, and you can just go blindly adopt them at your company.
It's kind of what we said not to do, but
do it anyway, right, as they said. So
your fault, blame.
Yeah, you get blamed. Blameful premortems. I knew I was going to blame someone, right? One of the areas that I really found confusing when I was looking at SLIs was what period of time we were talking about studying it. And really, there were 3 major kind of time segments, right? One was the 30-day rolling. What's your full time window? One was how fast is your system consuming the data? Is it in 10 seconds? Is it a minute? Is it in half a second, a millisecond, whatever? You're usually consuming it in some sort of bundle. The other one was when I'm doing predictive, like how is it going to work in the future? What is my sample data set that I'm using to predict the future? And we bring this up really just as a community service, like because we spend a lot of time arguing about it. So these are some useful formulas, and not on purpose, but there is one typo in here, so really do test. Then these are also what we're looking at as kind of how do we move from just a measure of where we are into predicting the future, right? And what's some basic version of this? And one of the problems we've seen is you gotta be able to explain what you're doing to people. And so even though there are areas where we're actually trading off accuracy for explainability. So this is basically slope.
Yeah, you can't put a chart out there and not be able to tell people why and what is going into that chart. Right? So
usually
you have to be able
about
to have these
5 minutes. This is about the time you get, 5 minutes. So with that, I think it's time for snacks, right?
I love food. We talked about this. There's no more sour cream, though. I ate it all.
You ate all the sour cream. So.